In the previous section, we only talked about probabilities where there's only one event. In this section, we'll talk about calculating probability when there are two events. There are two choices. If you have event A and event B, there's a chance that the events are overlapping, like in the left case. Or if you have event A and event B, there's a case that the events are disjoint. They don't overlap at all. And this is important because how you calculate it's different. So the first thing you need to do when you're given a problem with two events is determine whether the events are overlapping, like can they share some characteristics, or are they disjoint, in which case they share none. If they're overlapping, and it asks you what's the probability of A or B occurring, you need to find the probability of A plus the probability of B, subtract the area that they share to get the full area. So subtract A and B, because it'll just give you the area where A or B occurs. But there's some area in the middle that's redundant. We need to subtract that away from it. If the events are disjoint and they don't overlap at all, then we calculate this probability. When it says what's the probability of A or B occurring, it's just probability of A plus the probability of B. So it's actually a lot nicer when it's disjoint because we don't need to subtract anything afterwards. The first example says a card is randomly selected from a standard deck of 52 cards. What's the probability that it's a 10 or a face card? So we have to first think, is it possible for it to be both? Can it be a 10 or a face card? I mean, can it be 10 and a face card at the same time? The answer is no, because the face cards are Jack, King, and Queen, and 10s are just 10s. So they don't really overlap at all. So we're just going to find the probability that can be one of those three. Probability of it being 10, and we're just going to add them together. So in a deck of 52 cards, there are 4 10s. So we're going to say 4 over 52. That's the first probability. Plus, okay, of these, there's 4 jacks, 4 kings, 4 queens. So that gives us 12 options out of 52. We're just going to add those together because these events are disjoint. The denominators are the same, so we can just add it together. 16 over 52. We can reduce that. Start by dividing by 2. 8 over 26. 4 over 13. All right, let's go to the second example. It says, once again, take a card. What's the probability that it's a face card or a spade? So we have to first think, is there a chance that it's a face card and a spade? The answer is yes, because you can have the king of spades, the queen of spades, or the jack of spades. So these are 3 possibilities where it's both. So we're going to find the probability of A or B. And because these events are overlapping, we're going to have the probability of A plus the probability of B minus A and B. So we'll say probability of A is that it's a face card. Like we said in the last example, there are 12 out of 52 face cards. Probability that it's a spade, that's 13 out of 52. There are 13 spades in the deck. Then we're going to subtract the probability that it's both, which is just king of spade, queen of spade, and jack of spade. So 3 over 52. Combine those, we get 25 minus 3, 22 over 52, 11 over 26. The probability that's a face card or a spade. One more example for you. It says, out of 200 students in a senior class, 113 students are either varsity athletes or on the honor roll. There are 74 seniors who are varsity athletes, 51 who are on the honor roll. What's the probability that a selected senior is both a varsity athlete and on the honor roll? So the first thing we need to decide is, are these overlapping or are they disjoint? So can a student be a varsity athlete and on the honor roll? The answer is yes. So they are overlapping. So we set up the equation, probability of A or B equals probability of A plus probability of B minus probability A and B. That's our generic equation for overlapping events. Now we're going to plug in the information we have. It says 113 students are either varsity athletes or on the honor roll, so we actually plug that in here. The probability is 113 over 200 students total. equals PA, we're going to say that's varsity athletes, that's 74 over 200, plus probability B, we'll say that's honor roll, so 51 over 200, minus P, A, and B. Because we don't know how many students are both athletes and on the honor roll, but we can solve for it. Let's go ahead and combine 74 and 51 to get 125 over 200 minus probability A plus B. We'll subtract that to get if we subtract this to the left side, we're going to have negative 12 over 200 equals the negative probability, A plus B. And that seems really weird, but since they're both negative, let's just change them both to being positive and make it easier on ourselves. So the probability that it's A and B at the same time, that they're varsity athlete and on the honor roll, is 12 over 200, which we can reduce to 6 over 100, and that reduces to 3 over 50. So there's a 3 out of 50 chance that a student is both. The last concept from this section is about a complement. And all a complement is 1 minus the probability of that thing. So like in this last example, we ended up with 3 out of 50. The complement of 3 out of 50 is 1 minus 3 over 50, because that's how you solve for complement. So if this is probability of A, of course that's not what we called it in the last example, but that's what we'll call it here. This is the probability of the complement of A. It says A with a line over the top of it. To solve that, we got to put that as 50 over 50. That's 1 minus 3 over 50. So the complement of the problem we just solved is 47 over 50.